Today we're going to solve equations by factoring. Hopefully you have this here, our factoring foldable that you made in one of the previous videos. It's got all the different examples, factor trees, binomials, trinomials, and then on the back side it should have like the 4 steps to go through how to solve, not solve, but how to simplify an expression. So I got some problems up here, and we'll probably end up doing some more here. But we're going to solve these equations by factoring. So the first step that we're going to do is to factor it. And then after that, I'll show you the last step, how to solve it by factoring. So today's goal is to solve the equation by factoring. Up to this point, we know how to solve a quadratic by graphing it in our calculator and see where it crosses the x-axis. We know how to take the square root, and today we're going to learn how to solve it by factoring. So here we go. If you're going to solve it by factoring, make sure your problem equals 0. So this problem right here is already equal to 0, so we don't have to do anything. But the other problems, as you see up here, we're going to end up having to do something to them because it has to be set equal to 0 first. So the first thing we're going to do is factor it. Your first step when you factor is to find the greatest common factor. So we want to look up here and see what numbers or variables do they share. I see that this has an x, and I see that this has an x. So their greatest common factor is x. And everything else is going to go on the inside. So if I take one x away, what's left over? 2x. If I take an x away, what's left over? Negative 11. And the wonderful thing with factoring is that you can check yourself by multiplying it back out. X times 2x is 2x squared. X times negative 11 is negative 11x. From here, you set each factor equal to 0. X is a factor, and 2x minus 11 is a factor. Set both of those factors equal to 0. So x is equal to 0, and 2x minus 11 is equal to 0. So we set both of those problems equal to 0. Both of those factors equal to 0. There's nothing to do here, so this is my answer. Over here, we solve it like a regular equation. So I'm going to add 11 to both sides. And then I'm going to divide by 2. So that my answer is 11 halves. So our 2 answers for this problem, if I were to solve this problem by factoring, my 2 answers are 0 and 11 halves. So my 2 answers are 0 and 11 halves. I also want to note that if you were to solve this by graphing it, it would cross the x-axis at 0, and it will cross the x-axis at 11 halves, which is about 5.5. So 1, 2, 3, 4, 5, go a little bit over. So it will cross the x-axis at these 2 spots. So just a little side note there. So graphing and factoring give you the same answer. Some methods work for some particular problems, some don't. But in this case, I could have solved this one by graphing it, and I would have got 0 and 5.5. But today's focus is on how to solve it by factoring. So let's keep going. Let's try some more. So if I look at number 2 here, x squared minus 14x equals negative 45, it's not equal to 0. So I need to take this negative 45 and I need to move it over. So the opposite of a negative 45 is a positive 45. So we're going to add 45 to both sides. Now, these are not like terms. Like terms have the same variable and the same exponent. This is x squared. There's no other x squares. This is a regular x. There's no other x's. And this is a constant. So none of these are like terms. So when I rewrite it, it'll be x squared minus 14x plus 45 is equal to 0. So I kept everything separate because none of these are like terms. Now we're going to factor this like we normally would. So we'll set up our parentheses. Something times something has to give me x squared. Now we're looking for 2 numbers that multiply to give me a positive 45. Add to give me negative 14. So again, 2 numbers multiply to give me positive 45, add to give me negative 14. So things that give you 45 is either going to be 9 and 5 or 15 and 3. But I need to get a negative 14 in the middle. So I know my sign should be a negative because a negative times a negative gives me a positive. And I need numbers that are going to add to give me negative 14. So my numbers should be 9 and 5. So negative 9 times negative 5 is positive 45. Check. Negative 9 plus negative 5 is negative 14. So we're in business. And the last step, since we're not just factoring today, since we're solving by factoring, my last step is to take this factor, set it equal to 0, and take this factor, set it equal to 0. So we'll go through, solve our equations. These are simple equations. Add 9 to both sides. We'll get 9. Add 5 to both sides. We get 5. So my two answers are 9 and 5. I do want to note that since these are quadratic equations and the highest exponent is 2, that's why we're getting 2 answers. If my highest exponent was 3, we'd get 3 answers. If it was 5, we'd get 5 answers. But my highest exponent is 2, so I'm going to get 2 answers. All right, let's take a look at number 3 over here. 3x squared is equal to negative 12x. Again, it's got to be equal to 0. This is equal to 0, and this first one that we did was also equal to 0. Even if you were to try to solve something by graphing, that still needs to be equal to 0. So I need to set this equal to 0. I think it's easier if you take this term and move it to the other side. So we're going to add 12x to both sides. The reason I think it's easier is because your quadratic term will be positive. So if you move it to the other side, you're going to have to factor out a negative, and it'll be a little harder for you to do. But I'm just going to try to give you like some easy ways to do things. So add 12x to both sides. So these are not like terms. This gives me 3x squared plus 12x equals 0. Your first step when you do any kind of factoring is to check for a greatest common factor. Number 2 did not have a greatest common factor. Number 1 had a greatest common factor, that was x. And looking at this one down here, it looks like they're going to have a greatest common factor also. They both share x. And I also can see that this is 3 and this is 12, and the biggest number they share is the number 3. So their greatest common factor is 3x. 3, if I take the 3 and the x away from here, I'm left with an x. And 3x times something has to give me 12x. So 3x times something has to give me 12x. That something that we're missing is 4. Beautiful thing about factoring is you can check your work. 3x times x is 3x squared. 3x times 4 is 12x. So that's exactly what I have up here. Set each of your factors equal to 0. So 3x is equal to 0. X plus 4 is equal to 0. Divide both sides by 3. We get 0. Subtract 4 from both sides. We get negative 4. So 2 answers because my highest exponent is 2. And my 2 answers are 0 and negative 4. And again, graphing and factoring give you the same answer. Not everything can be graphed and find your answer because it has to be where it crosses the x-axis. And not everything can be factored because what if you get 2 numbers that don't multiply to this and add to give you that? So, but I will be teaching you more methods as it goes on. I would like to try a couple of more just to make sure you have enough example problems. So today, not only are we factoring, but we're solving equations by factoring. So if you need to pause this video, I'm going to start erasing stuff so that I can put a few more practice problems up here for us. All right. So I got 2 more for us. This would be number 4. We're going to do x squared equals negative 4x plus 21. And then the last one, I want to take a look at the 4-step method. Okay. So those are going to be the last two problems that we'll take a look at. Okay. Neither one of these are equal to 0, so we definitely want to set up the problem so that they are equal to 0. Now, a few minutes ago, I told you about this right here. You could absolutely subtract x squared from both sides so that you had negative x squared minus 4x plus 21. However, I think it's easier if you make this quadratic term be positive. That way you don't have to worry about factoring out a negative. So instead, I'm going to add 4x and I'm going to subtract 21 to both sides. So that I have x squared plus 4x minus 21 equals 0. So what I did is I moved these two terms to the other side of my equal sign. Now we will factor like we normally would. So I'll set up parentheses. Okay, I got an x and an x. Now we got to think of two numbers that multiply to give me negative 21, add to give me 4. Multiplies to give us negative 21, adds to give us 4. So things that give us negative 21, we know it's got to be a 7 and a 3. My sign is negative, so one has to be negative and one has to be positive. So if I want a positive 4 in the middle, the big number should be 7, and this is a little number. Great thing about factoring, we can multiply it out. If you were to multiply this out, of course, you would do the box method or distributive property. And when you multiply these two things out, it would give you x squared plus 4x minus 21. Now, we are not finished yet. Today's objective is to solve a quadratic equation by factoring. So I'm going to take each of these and I'm going to set it equal to 0. So x minus 3 equals 0, and x plus 7 equals 0. Add 3 to both sides. Subtract 7 from both sides. So my answer is 3, and my other answer is negative 7. And making some connections here so that we are tying things together and building on our knowledge. If I were to graph this one, of course, it would still have to be equal to 0. If I were to graph it, I'm looking for where it crosses the x-axis, and it will cross the x-axis at positive 3 and negative 7. So 1, 2, 3, it will cross here. And 1, 2, 3, 4, 5, 6, negative 7. And there's something approximately like this. Okay. Rough sketch. Bear with me, rough sketch. But you can use Desmos to get a more accurate answer. But it will cross the x-axis at negative 7 and positive 3. And last one, we got number 5. Again, if you need more time to write, as always, you're more than welcome to pause the video and get what you need there. All right. It's equal to 66. We need it to be equal to 0. So, of course, we'll subtract 66 from both sides. These are not like terms. One's a square, one's a linear, and one's a number. Okay. Now, first step is to check for a greatest common factor. 2n squared, negative n, and negative 66 do not have anything in common. So they do not have a greatest common factor. So instead, we're going to do the 4-step method that is on the back of your foldable here. And we have the 4, there we go. Multiply the first and last number, factor like normal, divide by the first number, and then get rid of fractions. So these are the steps that I'm about to do to help us factor this problem, then solve it. So step 1, multiply the first and last number. So n squared minus n, 132. So step 1, we multiply the first and the last number, brought everything else down. Step 2. Step 2 says to factor like normal. So we're looking for or thinking of two numbers that multiply to give me negative 132, add to give me negative 1. So multiplies to give me negative 132, adds to give us negative 1. So you can use a calculator or Desmos or something like that to help you out. Those numbers are positive 11 and negative 12. Step 3, divide by the first number in the problem. First number in the problem is the number 2. So I'm going to divide by 2. Divide by 2. So step 3, n plus 11 half n, reduce, always reduce, minus 6. And last step, because it's a 4-step process, I need to get rid of fractions. So I have a fraction over here. So I need to multiply this whole thing by the denominator, which is 2. So I need to multiply just this part by positive 2. 2 times n is 2n. 2 times 11 halves is 11. N minus 6. Okay, hopefully you're good to go. Now, the question didn't say factor it. It said to solve it by factoring. So we're 98% done. I need to take these two factors and set them equal to 0. So I'm going to come up here, and I'm going to set these equal to 0. So 2n plus 11 is equal to 0. And n minus 6 is equal to 0. Subtract 11 from both sides. Divide by 2. We got negative 11 halves. Add 6 to both sides. And we got 6. So our two answers are negative 11 halves and positive 6. So my two answers, negative 11 halves and positive 6. So recap. We're going to use all the good things we've been working on over the past few days. Factor, factor, factor. Hopefully you have this from the previous video. So factor, factor, factor. After you factor, the last only additional step is that you set each of your factors, which are generally the things in parentheses. You set each of those factors equal to 0 and solve your equation. And those will give you the solutions, the zeros, the roots of our equation.